Hello friends, welcome back once again to Physics Made Easy by Guru Sharma. In this video I am going to tell you the torque acting on electric dipole placed in a uniform electric field. In this video we will discuss how does an electric dipole behave when it is placed in a uniform electric field. Okay, so first of all let us draw uniform electric field. We draw uniform electric field like this. The parallel field lines with equal gap represent uniform electric field. The gap between the field lines is same, so the electric field is uniform. Now if we place an electric dipole, suppose this is the electric dipole having charges -2 and +2. Let this dipole is placed at angle theta. This dipole is making angle theta with the direction of electric field. Okay, we take, suppose this is the center of dipole and let us consider the length of the dipole is 2. Now you know that as this dipole consists of two charges, -2 and +2, and we also know that whenever a charge is placed in some external electric field, it experiences a force. We know that F by Q naught is E. So if at any point electric field intensity is E, so and if we place a charge Q naught there, so force experienced by charge F will be Q naught E, right? Suppose this is the electric field E. Suppose this is the value of electric field intensity throughout this is E. Now this charge Q which is placed in electric field, it will experience a force, and the force on +2 charge, will be how much? +2E, and this force will be in the direction of electric field. So this charge will experience a force in this direction and this force will be +2E, right? Now force on, if we find the force on -2 charge, force on this charge will be -2E, and this minus sign shows that the direction of this force will be opposite to the direction of electric field. Electric field is in this direction. If we place a negative charge in electric field, negative charge experiences a force in a direction opposite to field, and the positive charge experiences a force in a direction in the direction of the field. Okay, so force on this charge will be -2E. So if someone asks you what is the net force on an electric dipole in uniform electric field, what is the net translatory force? So if we add these two forces, so net translatory force on the dipole, net translatory force on the dipole will be +2E -2E is equal to 0, right? So net translatory force on electric dipole in a uniform electric field is 0. Now if we see these two forces +2E and -2E, they are equal in magnitude and opposite in direction. They are equal and opposite forces, but their line of action is different. The line of action of this force is this one, and the line of action of this force is this one, and such type of forces which are equal and opposite and acting along different line of action, they constitute a torque. We have already studied in 11th class. Such type of forces constitute a couple. Suppose I have a rod like this and there are two forces acting on this rod. Suppose one force is acting in this direction, another force in this direction, and if they are equal and opposite, then this rod will rotate about this point. If the rod है इस point के about ये rotate करना शुरू करेगी. So these two forces they will make a couple, or you can say torque. So these two forces +2E and -2E, which are equal and opposite and acting along different line of action, so they will constitute a torque, and dipole will start rotating about this point, about this axis of rotation. So let us find the formula for that torque. So we know that torque or couple is equal to magnitude of any one of the force. You can take any magnitude of any one of the force into perpendicular distance between what? Between their lines of action. Perpendicular distance between the lines of action of two forces, their lines of action. So the line of action of this force is this one, and the line of action of this force is this one. Suppose this will be the perpendicular distance. Suppose this -2 charge is placed at point A and this +2 charge is placed at point B, then this BN we can take as the perpendicular distance. So let us find Bn. If this angle is theta and this is also theta, from this triangle B and A, or A and B, we can see that sin theta is perpendicular Bn upon hypotenuse AB. And we know what is AB. AB is the length of the dipole, which is 2a. Okay. So Bn will become, Bn comes out to be 2a sin theta. So this Bn is the perpendicular distance between the lines of action of these two forces. So the formula for torque, magnitude of torque becomes force QE. The magnitude of these two forces is same. This is QE and this is also QE. And the perpendicular distance between their lines of action is 2a sin theta. Right? Now we know that this Q into 2a. You know that Q into 2a. This Q into 2a is known as P, the electric dipole moment vector P. This is P and this is E and this is sin theta. So this becomes the formula for magnitude of torque acting on electric dipole placed in a uniform electric field. So we conclude that whenever an electric dipole is placed in a uniform electric field, it experiences a torque, and the net translating force of the dipole is 0. Right? So using this formula, you can just only calculate the magnitude of torque. Now, but torque is a vector quantity. Torque is a vector quantity. So on the basis of the net torque or rotation of the dipole, on the basis of rotation of dipole, the direction of rotation of the dipole will decide that what will be the direction of torque. And according to that, this torque comes out to be P cross E. This direction of rotation of dipole decides that torque will be P cross E and not E cross P. Whenever we place an electric dipole in electric field, dipole rotates, and that rotation occurs in such a way that the torque comes out to be P cross E. Right? So, and from the properties of cross product, you already know the cross product of any two vectors. The cross product of any two vectors is another vector which is perpendicular to both the vectors. From here, this torque will be perpendicular to dipole moment, and this torque will be perpendicular to electric field also. Right? Direction of this torque you can find using Fleming's left-hand rule or screw rule that we use to find the direction of cross product. Now we can take two special cases. Special case 1, if dipole is placed like this, if dipole is placed parallel to electric field in such a way like this, that the direction of dipole moment P vector and the direction of electric field both are in the same direction. If the direction of dipole moment and electric field both are in the same direction, then theta will be 0. If P and E are in the same direction. Okay, so in that case theta will be 0, so torque will be 0. So dipole will not experience any torque. But if theta is 180, if dipole is placed like this, if P and E are in an opposite direction, like this, -2 in this direction and +2 in this direction, you know direction of dipole moment is from negative to positive charge. So direction of dipole moment vector will be this one. So P is in this direction and E is in that direction. So theta will be in this case, case 2, theta will be 180, and you know sin 180 is also 0. So torque again will become 0. And this position of the dipole in which theta is 0, angle between P and E is 0, this is called stable equilibrium position. We call it stable equilibrium position. Okay. And this position of the dipole, this orientation of the dipole in which theta is 180, this is called unstable equilibrium position. Okay. And the third case, the last one, when theta is 90, case 3, you can take if theta is 90. That means dipole is placed perpendicular to electric field. Suppose like this. Dipole is placed like this. So in that case torque will become PE, and this will be the maximum value of torque. So friends, in this video I discuss the torque acting on electric dipole placed in a uniform electric field. Hope you enjoyed it and you have learned the topic. Thank you very much. If you like it, please share my video. Thank you.